So what we are working on today is rationalizing a denominator. We have to rationalize the denominator of a fraction if you have a radical down there, because you can't have a radical in the denominator of a fraction. It's just not allowed. So we rationalize the denominator by multiplying the top and the bottom of a fraction by that radical in the denominator. So you're always multiplying by the radical. Whether it be a square root, cube root, fourth root, fifth root, whatever that radical is in the denominator, that's what we're multiplying by. So in my example here, I had a radical 2 in the bottom. So as you can see, I multiplied the top and the bottom of my fraction there by that radical 2. Now multiplying the top and the bottom by that same thing, as you can see by my little outline here, is it's really the same as multiplying it by a 1. Because anything over itself is 1. So I'm not changing my fraction. I'm just finding another way of writing it that's still equivalent, but a little bit different. So multiply top and bottom by that radical. So then here's my work. I get 10 times radical 2, which is 10 radical 2. Radical 2 times radical 2 is radical 4, which turns into a 2. So now we don't have a radical in our denominator anymore. That was our goal. And then 10 divided by 2 gives us a 5. So we'll just multiply by that radical sign. So let's take a look at our examples. So first one, we have 3 over radical 3. So I'm going to multiply both the top and the bottom by that radical 3, because we can't have that radical in our denominator. So then we're just multiplying across. 3 times radical 3 is 3 radical 3. Radical 3 times radical 3 will give us a radical 9. What is the square root of 9, though? 3. So that bottom turns into a 3. Now we don't have a radical anymore in there, which is what we wanted. But then we got to reduce, so what happens to these 3's on the outside? They cancel. So our answer just becomes radical 3. So our second one, that whole thing is under one radical sign. So let's split that up first. So I'm going to give the top its own radical, and I'm going to give the bottom its own radical. But the top is just kind of like glaring at me, because what's 64? It's a perfect square. What is the square root of 64? So I'm going to change that first. So I got 8 over radical 7. So again, I can't have that square root of 7 in my denominator, so I'm going to multiply top and bottom by the square root of 7. So 8 times the square root of 7 gives me 8 radical 7. Radical times 7 times radical 7 would give us radical 49. Which radical 49 turns into 7. And then can I reduce my 8 and my 7 that are both out of the radicals? No. So this is our final answer here. All right, number 3, it's already split up. So I'm going to go ahead and just start my multiplying. I don't want my radical 6 down there. We're going to multiply top and bottom by radical 6. So remember, when we're multiplying, 3 times 6 gives us 18. Numbers under radicals can be multiplied together. Numbers in front of radicals are multiplied together. So that gives me over a radical 36, because 6 times 6 gives us 36. Now can we simplify this radical 18? Is there a perfect square that goes into 18? 9. Somebody said 9. So our 18 would break up into radical 9 and radical 2, just like what we were doing before, what you did on your quiz today. Square root of 9 is 3, so I'm going to turn that into a 3. 2 times 3 gives me 6 radical 2. That's in our top, so we've simplified our top. In the bottom, square root of 36 is 6, so I'm just going to carry my 6 through. And then can I reduce? Yeah, those 6's cancel. And we get radical 2 as our answer there. All right, let's try a few more on the back. So number 4, we got 15 over 2 radical 5. But as I said on the front, we only have to multiply by the what? By the radical. So even though there is a 2 there, we still just multiply top and bottom by the radical, so still just by radical 5. So I get 15 radical 5 over 2 radical 25, because I still follow my multiplication rules. 5 times 5 gives me 25, which the square root of 25 is 5. So in my denominator, I end up with a 10, because I got the 2 times that 5 there. And then can we reduce? Yeah, what number goes into 15 and 10? 5. So 15 divided by 5 is 3. 10 divided by 5 is 2. So I got 3 radical 5 over 2. All right, number 5 again. First thing I'm going to do, write top and bottom with their own radical sign. So radical 8 over radical 10. So then what are we going to multiply by? Radical 10. So following our multiplication rules, 8 times 10 gives me a radical 80. 10 times 10 gives me a radical 100. So then we have to think to ourselves, is there a perfect square that goes into 80? 16. So 80 is going to break up into 16 and 5. Square root of 100 for our denominator will become a 10. What is the square root of 16? 4. 4 radical 5 all over 10. Is that as simplified as we're going to get? Perfect. We can divide 4 and the 10 by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. So 2 radical 5 over 5. So number 6, same thing as I did for the last one. I'm going to separate it. It's top and bottom each have their own radical. So I got radical 7 over radical 2x. So what are we going to multiply by? Radical 2x. Multiply by that denominator. So 7 times 2x gives us a 14x. 2x times 2x would give us a 4x squared. Is there a perfect square that goes into 14? Nope, because 14, it's just 1 times 14 or 2 times 7. None of those are perfect squares. So our radical in the top is going to stay as radical 14x. For the bottom, square root of 4 is 2, and then remember, divide your exponents by 2. So we would get a 2x for our bottom. And then our last one again, give the top and the bottom their own square root signs. The bottom, that 16 sticking out to me though. What's the square root of 16? 4. So I'm going to actually fix that and make it 4 radical x. Because the 16 is a perfect square. It can come out of the radical. X, however, is not. And now our radical is just a little bit smaller that we're going to multiply by. So the square root of x over the square root of x is what we're going to multiply by. So that gives us 3x to the 4th up top under our radical sign. And then in our denominator, we get 4 times square root of x squared. We do have a perfect square in our numerator. That would be the x to the 4th. So I would separate my x to the 4th from my 3. In the denominator, what is the square root of x squared? So our denominator becomes 4x. And then the square root of x to the 4th would be x squared. You just divide your 4 by 2. So x squared square root of 3 all over x to the 4th is our final answer. I'm sorry, 4x.